Coders, welcome back to my YouTube channel. Today I'm going to solve LeetCode problem number 997. Find the town judge. So in this problem we are given the value of n, which are the number of people, and each person is labeled from 1 to n, and there is one town judge in the people. There may be, so if there is a town judge, then the town judge satisfies these two criteria. That is, the town judge trusts nobody and everybody except the town judge, except the town judge trusts the town judge. Now we are also given an array trust where the value at index I is equals to an array with two elements, the first element AI and the second element BI, which means that AI trusts the person labeled BI. And now we know that we are given the trust array and the number of people. We need to find the town judge, and there may be no town judge. In that case we'll return -1. So now let's see how we could actually find the town judge. Let's look at this condition first. What the first condition says is that town judge trusts nobody. So if we are given the value AI and BI, which means that AI is not the town judge, but BI could be a possible candidate of town judge, right? So what we will do is, since AI is not a town judge at all, so okay, next let's see the second condition, that is everybody trusts the town judge except the town judge himself. What does everybody means? If there are n number of people and there is one town judge in the town, which means that the remaining people n-1 will trust that town judge. So the number of people, the count of people trusting the town judge should be equals to 1. What does that mean? Is the number of AI where the value BI is equals to the label for the town. So suppose the label for town judge is X. That is, if X is the town judge, then in the condition where BI is equals to X, the total number of count for AI should be equals to n-1. So if we look at this case, what we will be actually doing is we'll be counting the number of people for each BI. So we are going to use an array for that, and we will keep the count of so that means BI where BI is equals to X will appear n-1 times. So we are going to keep the count of BI. Every time BI appears, any value for BI appears, we are going to increase the count by 1. And every time a person appears at first index, that is as AI, we are going to reduce the count by 1. So any person who is not a judge will basically have the value for count less than n-1, and for the judge it will be equals to n-1. Now let's look at this example. So there are 4 people here, right? This is 1, this is the second person, this is the third person, and this is the fourth person here. So now since we have 4 people, this person is labeled 1, this is labeled 2, this is labeled 3, and this is labeled 4. All right. What's said here is 1 trusts 3. Since 1 appears at the first index, that is as AI, which means that it will not be a judge at all. So we reduce the count by 1, so the value becomes equals to -1. And Next is 1 again. Next is 3, the value 3, which means that 3 may be a possible candidate for judge. So we add 1 again, we encounter 1 and as AI, so we take a -1 again, and then 4 we take a +1 for 4 since it's at the second index. 2 it appears at the first index as AI. 3 is equals to BI, so we get a +1. 2 is again is AI, -1 we get a 4, so we take a +1 again for 4 and we get a 4 again as AI. So what are we doing is we are now taking a -1 and then we get a 3, so we take a +1 here. So now what's the result? It's -2 here, -2 here as well. For this it's 3 and for this one it's 1. And what's n-1 here? N-1 is equals to 3, right? So since this value has 3, this person has 3, so we are going to return this as our judge. If none of them had the value equals to n-1, then we would have returned -1. Now that we know what the logic is, let's try to code it. So what we need is an array to keep the count, right? So we are going to create an array of length n+1 because we are not going to use the index 0 since there is no person labeled index 0, labeled 0. It's starting from 1 to n, so that's why we want the last index to end at index n, and we are going to fill all the values with 0. Now starting from the first of trust count, so for A, which means that A will never be a judge, but B could be a judge, right? So B we are going to add +1, and then finally we are going to loop over the value of count I equals to 0, I is less than n+1, I plus. All right, I should not be, we are actually not going to check for 0 because there is no person labeled 0. So we start from 1, and if the count is equals to n-1, then we found our judge and we're going to return the value I for the count of that person. Else we are going to return -1 because there is no judge. Now let's try to run our code and see. Cool, let's submit it. So the time complexity of this function is O of n, and the space complexity is O of n as well.